we want to solve the given system of equations using the substitution method. Before we do this, let's review the steps for solving a system using the substitution method. In general, step 1 is to solve for a variable in one of the equations. Step 2, we're going to substitute in the other equation for the variable isolated or solve for in step 1. This will give us an equation with one variable. So step 3 is we're going to solve the resulting equation. This will give us the value of one of the variables. And then for step 4, we'll perform back substitution to solve for the other variable. And then step 5, the recommendation is to check the solution. So going back to our example, notice how both equations are already solved for y, therefore substitution is probably the most obvious method. If we look at equation 1, we're told that y equals negative 6/5 x plus 7. So wherever we see a y, we can replace it with this expression. So in the second equation, we're going to perform substitution or replace y with negative 6/5 x plus 7. When we do this, it's going to give us an equation with just x. So we would have negative 6/5 x plus 7 equals the right side of this equation, which would be negative 5/2 x plus 20. Now to solve this equation, we could work with the fractions, but it's probably going to be easier if we clear the fractions by multiplying both sides of the equation by what would be the least common denominator, or the least common multiple of 5 and 2, which would be 10. So now we're going to multiply both sides of the equation by 10 to clear the fractions. Again, we don't have to do this, but it's probably going to be easier to solve this without fractions. So now we'll distribute here as well as here. So for this first product, we would have 10 times negative 6/5 x. We can think of this as 10 over 1 times negative 6/5 x. Notice how here we have a common factor of 5. There's 1 5 in 5 and 2 5s in 10. So we have 2 times negative 6x. So we'd have negative 12x. And then 10 times 7 would be 70. So we have plus 70 equals, on the right side we'd have 10 times negative 5/2 x, or 10 over 1 times negative 5/2 x. Again, the 2 and the 10 simplify. There's 1 2 and 2 and 5 2s in 10. So we have 5 times negative 5x. That's negative 25x. And then 10 times 20 is 200, so plus 200. Now to solve for x, we need to have x on one side of the equation. So to undo negative 25x, we're going to add 25x to both sides of the equation. This would be 0, so we'd have negative 12x plus 25x, that's 13x, plus 70 equals 200. Now we'll undo the plus 70 by subtracting 70 on both sides. This would be 0, so now we have 13x equals, this would be 130. So we'll divide both sides by 13. And we have x equals 10. Remember, we're not done because the solution consists of both an x value and a y value that satisfies both equations at the same time. So we know x is equal to 10. Now we'll go back and perform substitution to find the value of y. So we can use either of the original equations to find y. Let's go ahead and just use this first equation. We know y is going to be equal to negative 6/5 times x, which we now know is 10, or 10 over 1, plus 7. And again, this simplifies. There's 1 5 in 5 and 2 5s in 10. So we have y equals, this would be negative 12 plus 7. So the y coordinate, or the y value, is negative 5. Remember, we can list the solution as an ordered pair, 10 comma negative 5. Or we can actually say x equals 10 and y equals negative 5. So we can express our solution like this, or like this. The last thing I want to mention, notice how both of these equations are solved for y, and these equations are actually in slope-to-intercept form. So we can always check our solutions by graphing if we want to, and I did take the time to graph these, so let's take a look. If we graph these two linear equations, here's the graph of our two lines. Notice how the point of intersection is here in black, and again notice how the x-coordinate is positive 10, and the y-coordinate is negative 5. So this graphically verifies our solution is correct. I hope you found this helpful.